Hello and welcome to Sir Optics Academy. In today's video, we'll be looking at a very important topic in the study of organic chemistry. We'll be looking at a topic known as isomerism. So, what is isomerism? Isomerism is a phenomenon or the occurrence of organic compounds with the same molecular formula but different structures. Same molecular formula but different structures. Different structures or different arrangements of atoms in space. When compounds have the same molecular formula but different structures, they are known as isomers. Therefore, isomers are compounds with the same molecular formula but different structures. Isomers are classified into two types. We have the constitutional isomers or also called structural isomers. We also have another type of isomer known as stereo isomer. Constitutional isomer or stereoisomer. Constitutional isomer is also divided into 5 types. We have number one of them called chain isomers. Apart from chain isomers, we also have positional isomers. We also have functional isomers or functional group isomers. We also have metamers. And then lastly, we have tautomers. Constitutional isomer is divided into chain isomers, positional isomers, functional isomers, metamers, and tautomers. Stereoisomers are also classified into 2. We have number one of them called geometric isomers, which is commonly known as the cis-trans isomers. And then we also have isomers that have an asymmetric center. Isomers with an asymmetric center. Under here, we have 3 types of isomers. We have 3 types of isomers with an asymmetrical center. We have number one of them known as enantiomers. Number 2 known as diastereomers. And then lastly, mesocompounds. In the course of this video, we will be explaining isomers and its division one by one. So if you are here, thank you so much for being here. So let's dive into the main aspects. So firstly, let's look at what is constitutional or structural isomers. Constitutional or structural isomers are isomers with the same molecular formula but different arrangement of atoms. They are isomers with the same molecular formula but different connectivity. Under constitutional isomers, we have the chain isomers. So chain isomers are isomers with the same molecular formula but different carbon skeleton. What I mean by different carbon skeleton is that they have the same molecular formula, but when it comes to the arrangement of their carbon-carbon linear chain, they are different. For instance, examples of chain isomers are N-butane and isobutane. So now let's look at the structures of these two compounds. We know that but indicates 4 number of carbon atoms, and then ANA indicating the alkane family. So we have carbon-carbon bonding to each other with a single bond. So this is N-butane. This carbon bonding to hydrogen, hydrogen, and another hydrogen. This carbon is bonding to 2 hydrogen, and then this carbon is bonding to 3 hydrogen. So this is the structure of N-butane. Also, we have the structure of isobutane. Isobutane. So now, we can both agree that these two structures are different. So they are isomers, but then because they are isomers, they have the same molecular formula. In N-butane, we have 4 number of carbons. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 number of hydrogen atoms. And then in isobutane, we have 4 number of carbon atoms also. We have 1, 2, 3, and then lastly 4. And then number of hydrogen, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 number of hydrogen atoms. So chain isomers are isomers with the same molecular formula but different carbon skeleton chain. We have a linear and then we have a branch. So they are isomers existing in the same functional group with the same molecular formula but different structures. Also, another example of chain isomers is N-pentane and 3-methylpentene. So going by the structures, pent indicating 5 number of carbon atoms. So this is 1, 2, 3, 4, and 5. So this carbon is bonding to 3 hydrogen. This bonding to 2. This bonding to 3. So for 2-methylbutane, we have 4 number of carbon atoms. 2-methylbutane, we have 4 number of carbon atoms. And then on carbon 2, we have a methyl group. And then on this carbon, it is bonding to 3 hydrogen. This bonding to 1, this bonding to 2, and then this bonding to 3. So going by the number of atoms we have in these 3 structures, we believe that there are 5 number of carbon atoms, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 number of hydrogen. So here we also have 1, 2, 3, 4, 5. 5 number of carbons, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 number of hydrogen atoms. So chain isomers are compounds with the same molecular formula but different carbon skeletal structure. So the second type of constitutional isomer that we'll be looking at is positional isomers. So positional isomers are isomers with the same molecular formula, the same functional group, but different position of their functional groups. Example, we have propan 1 ol and propan 2 ol. These are isomers with the same molecular formula, the same functional group, but different position of their functional groups. Let's draw the structures. We have 3 number of carbons, and then on carbon 1 we have an OH. OL is indicating OH. So on carbon 1 we have an OH. So this carbon is bonding to 3 hydrogen atoms. This particular carbon is bonding to 2 hydrogen atoms, and then this particular carbon is bonding to 2 hydrogen atoms. So for this we have 3 number of carbon atoms, and then on position 2 we have our OH. So propan 1O has 3 number of carbon atoms, and 1, 2, 3, 4, 5, 6, 7, 8 number of hydrogen atoms, and 1 oxygen. So propan 2O has 3 number of carbon atoms, and 1, 2, 3, 4, 5, 6, 7, 8 number of hydrogen atoms, and 1 oxygen. So these are isomers, positional isomers. Positional isomers are isomers with the same molecular formula, the same functional group, and but different position of their functional group in a compound, in a structure. Another example of positional isomers. Another example of positional isomer can be, let's use alcohol group again as another example. Pent 2O, propen 2O, and pentan 3-ol. So we have this 5 number of carbon atoms, and then on position 2 we have our OH. Here we have 3 number of hydrogen atoms, here 2, here we have 2 also, here we have just 1, and here we have 3 number of hydrogen atoms. And then on pentan 3O, we have 5 number of carbon atoms. And on position 3, which is this, we have an OH. So this is bonding to 3 hydrogen atoms. This is bonding to 2. This is bonding to 1. This is bonding to 2. And this is bonding to 3. So going by the number of atoms you have in each structure on carbon, in pentan 2O, we have 5 number of carbon atoms. And we have this 6, 10, 11, and 12 number of hydrogen atoms with 1 oxygen. On pentan 3O, we have 1, 2, 3, 4, 5 number of carbon atoms with 12 number of hydrogen and 1 oxygen. So these two are examples of positional isomers. They are compounds with the same molecular formula, the same functional group, but different position of their functional group in a compound. The third type of constitutional isomer that we'll be looking at is functional isomers. Number 3, constitutional isomers. Functional isomers. So functional isomers or functional group isomers are isomers with the same molecular formula but different functional groups. When it comes to functional isomers, they have the same structures. They have different structures, the same molecular formula, but different functional groups. For instance, we have propanone and propanal. So propanone and propanal are isomers with the same molecular formula, but different structures and different functional groups. The ONE in propanone is indicating the alkanone functional group, also called the ketone functional group, while the propanal is indicating the aldehyde, also called the alkanal functional groups. So going by the structures, we have 3 number of carbon atoms. The middle carbon is double bonded to oxygen. This particular carbon is bonding to 3 hydrogen, and this particular carbon is also bonding to. Another example of, for propanal, we have 3 number of carbon atoms, and the last carbon is double bonded to oxygen and 1 hydrogen. This particular carbon is bonding to 2 hydrogen, and this particular carbon is bonding to 3 hydrogen. So in propanone, we have 3 number of carbon atoms and 6 number of hydrogen atoms with 1 oxygen. So in propanal, we have 3 number of carbon atoms also and 6 number of hydrogen atoms and 1 oxygen. So these two are functional isomers with the same molecular formulas but different functional groups. When it comes to functional isomers, take note of the fact that alkanal forms functional group with alkanones. Alkanas forms functional group, specifically the functional isomers. They form functional isomers with alkanones. Also, alkanoic acid forms functional isomers with alkanoids. also known as the esters. Lastly, ether, also called the alkoxy, forms functional isomers with alcohols. So let's look at two more examples indicating ethers with alkanous and alkanoic acid with alkanoates. So let's look at propanoic acid and methyl ethanoates. So this is indicating the ester functional group, and this is indicating the alkanoic functional groups. So going by the structures, we know that prop indicates 3 number of carbon atoms, and the alkanoic functional group is RCOOH. So the last carbon is bonding to 2 double bonded to oxygen and single bonded to OH. So this particular carbon is bonding to 3 hydrogen. This is bonding to 2 hydrogen. So for methyl ethanoate, we have this. So the functional group of esters is RCCOR. So this particular carbon is bonding to 3 hydrogen, and this particular carbon is bonding to 3 hydrogens. So going by the molecular formula, this has 3 number of carbon atoms and 6 number of hydrogen atoms with 2 oxygen. So this has 3 number of carbon atoms also with 6 number of hydrogen atoms and 2 oxygen. So these two are isomers with the same molecular formulas but different structures. So functional isomers again are isomers with the same molecular formula but different functional groups. So lastly, let's look at the relationship between that of ethers and alcohols. So let's look at butanols and methoxy propanoate methoxypropane. So for butanol, we have 4 number of carbon atoms and the last carbon bonding to OH. So this carbon is bonding to 3, this is bonding to 2, this is bonding to 2, and also this is bonding to 2. So for methoxypropanoate, we have the structure. So here we have 3 number of hydrogen atoms. Here we have 2, 2, and 3. So the two structures are different, but when it comes to the molecular formula, we have the first carbon 4, and this 3 plus this 4 plus 6 is 10, with 10 number of hydrogen atoms and 1 oxygen. So when it comes to this, we have 1, 2, 3, 4 number of hydrogen atoms, 4 number of hydrogen atoms of carbon atoms, and this plus this 6 plus this 10 number of hydrogen atoms and 1 oxygen. So functional isomers are isomers that exist between different functional groups. Like I said before, alcohols exhibit functional groups with ethers, carboxylic acid with esters, and alkanes with alkanos. So we'll be looking at the next type of constitutional isomers, which is metamers. So metamers are isomers with the same molecular formula, the same functional groups, but different position of alkyl groups on both sides of oxygen, sulfur, or NH, indicating the nitrogen, which is amines. So metamers are compounds with the same molecular formula, the same functional groups, but different alkyl groups on either position of O, sulfur, or NH. For example, we have diethyl ether and methyl propyl ether. So going by the structure, we have diethyl ether, which is this. This carbon bonding to 3 hydrogen, this bonding to 2, this bonding to 2, and this bonding to 3. So the next is methyl propyl ether, which is this 3, 2, 2, and 3. So these are two different structures that exist between diethyl ether and methyl propyl ether. So in the first structure, we have 4 number of hydrogen atoms, of carbon atoms, and 10 number of hydrogen with 1 oxygen. So in the second structure, we have 4 number of carbon atoms, 10 number of hydrogen atoms with 1 oxygen. So metamers are compounds with the same molecular formula, the same functional groups, but different arrangements of alkyl groups on both sides of either oxygen, sulfur, or nitrogen. It depends on the type of functional group that you're dealing with. Another example is found in the functional group of sulfide. So this was an example of the functional group of ethers. So let's look at another example. Let's look at another example from the family of sulfur. So we have another example, let's say diethyl sulfide or methyl propyl sulfide. So going by the structure, there are 2 ethyl groups on both sides of the sulfur. So this carbon is bonding to 3, this is bonding to 2, 2 and 3. So here we have a methyl on one side of the sulfide and a propyl on the other side of the sulfide. So going by the molecular formula, this has 1, 2, 3, 4 number of carbon atoms with 3 plus 3, 6 plus 4, which is 10, and 1 sulfur. This also has 1, 2, 3, 4 number of carbon atoms and 10 number of hydrogen atoms with 1 sulfur. So these two are metamers with the same molecular formula, the same functional groups, with the same molecular formulas, the same functional groups, but different structures. So the last type of constitutional isomer that we'll be looking at is tautomers. Organic compounds are said to be tautomers when there exists a rapid equilibrium between two isomers. When there exists a rapid equilibrium between two isomers. That is to say that the two isomers can flip back and forth into each other very fast by moving a hydrogen atom and shifting a double bond. An example is found in keto enol tautomers, which specifically is between propanone and 2-propanol. So these two compounds can flip back and forth into each other by moving a hydrogen atom and shifting a double bond. So let's try to draw the structure of the two compounds. So these two compounds are referred to as tautomers. They have the same molecular formula, although different functional groups. This particular propanone have 3 number of carbon atoms with 6 number of hydrogen atoms and 1 oxygen. This has 3 number of carbon atoms with 6 number of hydrogen atoms and 1 oxygen. So these two compounds are referred to as tautomers. Reason being that there exists an equilibrium between them. So they can change, this particular compound, propanol, can change to 2-propanol, which can also change back to this. They can change by shifting a hydrogen atom and moving a double bond. Now, the double bond here is moved to this particular position, is moved from carbon-oxygen bond to carbon-carbon double bond. And then the hydrogen from the first carbon here is shifted to join with the O. So they can form tautomers by shifting a hydrogen atom and moving a double bond. Another example of compounds that undergo the tautomers process is found between Other isomers can also be found between ethanol and ethanol. These particular two compounds have the same molecular formula, but different structures, and these two compounds, ethanol and ethanol, can flip back and forth into each other, despite the fact that they have the same molecular formulas, but different structures. They are isomers, quite okay, but the type of isomers known as tautomers, because they can flip back and forth into each other by moving a double bond and shifting a hydrogen atom. So here we have two number of carbon atoms with four number of hydrogen atoms and one oxygen. Here we also have two number of carbon atoms, four number of hydrogen and one oxygen. So with all this being said, this is all about constitutional isomers. In summary, constitutional isomers are isomers with the same molecular formula but different connectivity of atoms. They have the same molecular formula, the same atoms, but different connectivity of atoms. We went ahead to say that we have 5 types of constitutional or structural isomers. We have chain isomers, which we said they are compounds with the same molecular formula, but different carbon skeletal chain, which we looked at an example between N-butane and isobutane. Went ahead to look at positional isomers. We said they are isomers with the same molecular formula, the same functional groups, but different position of functional groups in the compound. So next we looked at functional isomers. We said they are isomers with the same molecular formulas, but different functional groups. So we went ahead to say that functional isomers can be found between alkanols and ethers. They can be found between esters and carboxylic, and they can also be found between alkanones, which is a ketone group, and the alkana, also known as the aldehyde group. We looked at metamers. We said metamers are isomers with the same molecular formula, the same functional groups, but different arrangements of alkyl groups on either sides of oxygen, sulfur, and nitrogen. So lastly, we looked at tautomers. We said tautomers are organic compounds that have the same molecular formula, but they undergo a rapid equilibrium. They can flip back and forth into each other. If this flips to this, it can also flip back into this. So they flip by shifting a double bond and moving a hydrogen atom. So this is all for this video. In our next video, we'll look at stereoisomers, the types of stereoisomers, which is geometric, commonly known as the cis-trans isomers, and the stereoisomers with asymmetric center, which is divided into enantiomers, diastereomers, and meso compounds. So stay tuned, as part 2 of this video will be coming out soon. If you enjoy watching this video, please like and subscribe to this channel. Also, turn on the notification board so that you'll be notified anytime we drop a video on this channel. Thank you so much for watching.